Welcome to the explanation video for the May test of the Summerfield Open. This is the last one, guys. I hope you've enjoyed it. I know I have. Question number 1. Pete has a job for the 10 weeks of summer break. He makes $9 an hour and works 30 hours each week. The government takes 20% away in taxes. How much does he end up with? So this is really just a multiplication problem. If you start with 10 weeks and you say he works 30 hours each week, that's 10 times 30. And then you say he gets paid $9 per every hour, that's times 9, and that equals $2,700. So Pete will make $2,700, but that's before the taxes are taken out. Now we have to figure out the taxes. So taxes are 20% times the 2,700, so 20% times 2,700 is $540 in taxes. If you subtract what he made from what the taxes were, Pete will end up with $2,160 for the summer. And that's your answer. Question number 2. An elementary school student needs about 45 milligrams of vitamin C per day. An orange has about 51 milligrams of vitamin C. How many oranges would you need to get all of your vitamin C for the year? Again, this is a multiplication and division problem. First, let's figure out how much vitamin C we need in a year. You can take 45 milligrams per day times 365 days per year, and you get 16,425 milligrams of vitamin C per year. That's what a kid needs. Now, how many oranges will give you that much vitamin C? We can take the 16,425 divided by 51 milligrams in orange, and you get 322 oranges in a year. And that's your answer. Good job. Question number 3. What is the probability of rolling a 6-sided die 3 times and on the first roll getting an even number, on the second roll getting a 5 or higher, and on the third roll getting a 5 or lower? Well, we know with probability and probability of multiple events happening after another, you find the probability of each event and multiply them by each other. So what is the probability of getting an even number on the first roll? 3 over 6, or 1/2. There are 3 even numbers out of a total of 6 possibilities, so that's the probability of the first roll. On the second roll, the probability of getting a 5 or higher is 2 over 6. You could either get a 5 or a 6. So those are 2 options, so 2 over 6. On the third roll, the probability of getting a 5 or lower, there are 5 options. You could get a 5, a 4, a 3, a 2, or a 1. So 5 out of 6. And if you multiply all those together, 3 over 6 times 2 over 6 times 5 over 6, you get 30 over 216, which can reduce to 5 over 36. And you could actually divide that out and get 13.9%. And that's your answer, 13.9%. Good job. As I've always said, probability is one of those really great skills that not a lot of people know and not a lot of people are good at. So if you get good at this, you can really do so many awesome things. So I hope this inspires you to learn more about probability. We have our compound interest problem. You knew this was coming. Question number 4. Nugget, that's our dog's name, Nugget has $20 to invest today, and in 7 years he wants to buy $35 worth of bones. What interest rate would he need? So we know whenever we have these, we use the standard equation of S, what you start with, times 1 plus R, your interest rate, raised to the Y, the number of years, equals E, what you end with. S times 1 plus R to the Y equals E. Well, in this problem, we know what he's starting with. He's starting with $20. We don't know the rate. That's what we're going to need to figure out. We know he's going to do it for 7 years, and we know he wants to end with $35. Let's plug all those values into the equation, and we get 20 times 1 plus R raised to the 7th equals 35. And then this just becomes an algebra problem. The first thing we can do is divide 20 by both sides, and we get 1 plus R raised to the 7th equals 1.75. And then for these types of problems, we always need to get rid of the 7 in the exponent. And how do we do that? We can do that by raising both sides to the 1/7. Right there. So that 7 and 1/7 will cancel each other out. And just on the side, if you're doing this on a calculator, you can take 1 divided by 7, and that equals 0.1429. And then you can figure out what the left side, the right side of the equation is, 1.75 raised to the 1/7. You type in your calculator, 1.75 x to the y, 0.1429 equals 1.08322. So you put that back in your original equation. You have 1 plus r, the exponents cancel each other out, equals 1 plus 0.8322. If you subtract 1 from both sides, you get r equals 0.8322, which is 8.3%. And that's your answer. Nugget would need to invest his money at 8.3% to grow his money from $20 to $35 in 7 years. And we aren't done with compound interest yet. We're going to do one more. Adam invests $2,000 at 6% interest for 40 years. Pete invests half as much, $1,000, at 8% interest for 40 years. So Adam starts with more money but has a lower interest rate. Pete starts with less money but has a higher interest rate. At the end of 40 years, who has more and how much more? So let's look at this. We're going to use that same equation we always use, s times 1 plus r raised to the y equals e. And for Adam, his s is 2,000. He's starting with 2,000. The rate is 6%. The years is 40, and we don't know the e. And we can plug that into the equation and do 2,000 times 1.06 raised to the 40th. And that comes to $20,571. And just as a reminder, if you do this on your calculator, do the exponent first. Do 1.06 raised to the 40th, press enter, and then multiply that by 2,000, and you'll get the right answer. Now let's do it for Pete. He starts with $1,000, has 8% interest, and does it for 40 years. You do the same equation, just put in the right numbers. 1,000 times 1.08 raised to the 40th equals 21,725. And then to find out, so obviously Pete has more. To find out how much more, you just subtract those, and you get your answer. Pete has $1,153 more. I hope this was interesting to you, where you noticed that even though Adam started out with twice as much money, Pete having a little bit higher interest rate more than made up for it. That's the power of compound interest, and that's such a powerful concept that can take you so far in life, whether it's in finance, in science, in statistics, all sorts of things. That's a really, really important skill to have. So I hope you work on that, and I hope you've learned it and love it, and keep practicing that. The final question. This was definitely the hardest question of the test. How many ways can you arrange the letters in the word added? A-D-D-E-D. Well, we've done a problem like this before, where you can count the letters and you can say, well, added has 5 letters. And so we can figure out how many ways you can arrange it by using 5 factorial, that 5 with an exclamation point. And if you did that, you know 5 factorial is 5 times 4 times 3 times 2 times 1. And that comes with 120. So you might be tempted to think the answer is 120. And actually, a lot of you put 120. But that's not right. And the reason it's not right is because the word added has 3 duplicate letters, the D's. And so let's imagine that we arranged the word added like it is added, and we had the A first, and then the red D second, the blue D third, and E, and then the green D last. Theoretically, you could imagine rearranging it so you had A, and then the blue D, then the red D. You switched the order of those, and then the green D was last. Or you could have it so A was the first letter, and then the red D, and then the green D, and then the blue D was last. There are 6 different combinations here. And that 120 answer you got originally would assume that all these 6 different variations of the spelling A-D-D-E-D are different, because the order of the D's are different. But we know they all spell added. They're all the same. So we actually have to make a change. And what we do here is we realize that the 3 duplicate letters allow every way you can arrange the letters of the word added. You could rearrange the D's in that 3 factorial, or 6 different ways. Like we did here, you can see the spelling A-D-D-E-D. You could arrange that 6 different ways if you looked at each D as being unique, but obviously they aren't. Well, we need to take all those out. And we know that 3 factorial is 3 times 2 times 1, which is 6. So of all those 120 different combinations you found before, we need to divide that number by 6, because as we see in the middle of the screen, A-D-D-E-D, those aren't 6 different ways you can arrange the letters of the word added. It's just one, because all the D's are the same. If you do that, you'll have 5 factorial divided by 3 factorial, where 5 factorial is the total number of letters, and 3 factorial is the total number of letters that are duplicates, 3 D's. And if you do that, you get 120 over 6, which is 20, and that's your answer. There are 20 different ways you can rearrange the letters of the word added. Great job, everybody. You've stuck it out for a whole school year. We've had 8 of these tests, and I am so proud of each and every one of you for how hard you have worked, how much you've learned, how much you've studied. And it really did my heart good to see at the bottom of all the tests, when I asked, did you have fun? Every single person said yes. Every single one of you said yes. And I'm just thrilled at that. Math is fun. It's fun, and it can really change the world. You can do great, great things if you get good at math. And I hope this inspired you to get better at math, to learn more math, to learn more fun stuff like some of the things we learned, like compound interest and probability. And I hope you just take this and keep working on it and take it to the next level, and I know you will do great. In the meantime, have a wonderful summer, and I will talk to you soon.